In this next example, we are going to look at a problem that kind of involves supply and demand. This one has to do with a flight between two cities, but it could be anything with increasing prices, and a lot of times when you increase prices on things, you might lose some customers. So this one says a flight between two cities averages 81 passengers when the airline charges $210. The airline estimates that it will lose one passenger for every $3 fare increase. What is the maximum revenue generated by this flight, and how much should the airline charge to achieve this revenue? Well, right now, let's just understand this question right now. Right now, their revenue, as is they are charging $210 per passenger for 81 passengers. So that's how much they will make as is per flight. So let's do 210 times 81. This right now they're bringing in $17,010 per flight. What they're proposing is they think that if they increase the ticket price by $3, there's going to be a passenger that says, I'm not flying that anymore, or I'm not paying that, so they're down to 80 passengers. And so let's see what happens here. They did $213, only 80, but they actually gained in revenue by $30. And we could continue doing that. We could say, well, increase it again by $3. They're going to lose another passenger, so we could do 216 times 79, which it's still going up. Well, instead of guess and check, guess and check, guess and check, we're going to go ahead and try to think of a way to put this into a function. So we're going to have a revenue function. And the revenue function has to do with the cost per ticket, and that is multiplied by the number of tickets. All right, so let's take a look at this. Something changes. They do these price increases. So sometimes the tricky part of this is realizing that X is not going to be a dollar amount or a person amount. It's got to be something that relates them. So we're going to say X is the number of price increases or cost increases. Now, we're not saying that the cost increases by X, because if we put 1 in, it would just say the cost is increasing by 1, but it's increasing by 3. So this is just the number of cost increases. So let's come down to our function here and see how this plays out. All right, so our cost per ticket, the base cost was $81, but no, the base cost was $210. Sorry about that. Was $210, but they're planning on increasing that each time. And so for each cost increase, they're adding $3. So this should be 3x. So if x were 1, 3 times 1 is 3. 210 times, or plus 3 is 213. That's referring to this one. If we increase twice, that would be adding $6. That would be this next one. So that's the cost per ticket increases, but the number of tickets sold is going to decrease. It says they have 81 passengers, but they're thinking they'll probably lose one passenger per price increase. So 1 times x, or you could just put x. And so now what you want to do is you want to multiply this thing out. So here's our revenue function, and we're going to multiply this out. So actually 210 times 81, we actually did that up here when we distribute here. So we have 17,010. 210, so we multiply here, so that's negative 210x. 3 times 81 is 243x. And then 3x times negative 1x is negative 3x squared. Well, this looks like a quadratic function, so let's go ahead and change the order, putting these in descending order. We got negative 3x squared combining these two, that gives us 33x. And then we have plus 17,010. All right, so that's a quadratic function. Let's go ahead. We're going to move up here, and we're going to put that into the form where we can graph it. So we start by factoring out a -3. So we have -3. That's going to be x squared plus, actually minus 11x. We leave a space, and then plus 17,010. We want to complete the square here. Have the -3. Oops. I want to complete the square. So we can go ahead and use decimals here since we're dealing with money, and money deals with decimals. So we're going to take half of 11, which is -5.5, and we're going to square it. And we're going to, so that -5.5 squared, but it's multiplied by -3. So let's figure out what that's equal to. So we're taking let's put parentheses here so we get it right, -5.5 squared, which we know it's going to be positive, times -3. So we just added, or really subtracted, 90.75. So we want to go ahead and add 90.75 out here. And now we can finish our completing the square. This is 5.5 squared. Plus, we can add these, and that gives us 17,175 cents. And so thinking about this parabola, again, this, just like last example, we don't have to be exact. We want to do 5.5 and 17,175. That's going to be a parabola. It's going to be facing down. It's going to be fairly steep, but really we're looking for maximum revenue. So we're only concerned really with what that point is. That point is 5.5. So we want 5.5 price increases, which means for each one we increase $3. So we're going to do multiply 3 times 5.5. That's going to be 16.5. So you're going to increase the price by $16.05. It says, what's the maximum revenue generated by this flight? How much should the airline charge to achieve this revenue? Well, they should increase by 16.5, so take the 210 plus 16.5 gives us $226.50. And that will generate the $17,100.75. So maximum revenue, $17,175, and they should charge $226.05. Pretty cool question.